We're going to take a look at 3 examples of using the chain rule on this page. In example number 1, we're asked to differentiate. So f of x is x to the 4 plus 5 cubed. So this is a composite function. The x to the 4th plus 5 is the inside function. The power of 3 is the outer function. So the way you do the chain rule here is you differentiate the outside function. So the outside function is the power of 3. So to differentiate a power of 3, use power rule. The 3 comes down in front. We evaluate it at the original inside function, and then power rule, so the 3 exponent is subtracted by 1 to give you 2, decreased by 1. And then you multiply by that, on the last page it was called h prime of x, which is the derivative of the inside function. The derivative of x to the 4th plus 5 is 4x cubed. Just using power rule on x to the 4th would be 4x cubed. Remember, 5 is a constant, so its derivative is 0. So this part right here is the g prime of h of x, because we differentiated the power of 3, evaluated at the original inside function, and then we multiplied by the derivative of the inside function. So that's the differentiation finished. The only thing I would do to simplify this here is I'd multiply the 4x cubed by 3 to give us 12x cubed. So it would be 12x cubed x to the 4th plus 5 squared. In b here, before I differentiate, chain rule or not, I would write the cube root as the power of a third. So this is the same as having 6x to the 4th minus 2x raised to the power of a third. So once again, this is a function of a function. Here's the inside function, power of a third is the outside function. So I would differentiate the outside function first, so the power of a third. The 1/3 comes down in front, evaluate at the inside function to the power of negative 2/3, subtract 1 from the exponent to get negative 2/3, and then just like over here we multiply by the derivative of what's in here, we'll do the same thing here. We'll multiply by the derivative of 6x to the 4th minus 2x, which of course, power rule, 4 times 6 is 24, and subtract 1 from the exponent. The derivative of negative 2x is negative 2. So that's the differentiation finished. And then I would just want to simplify this. So this will be a radical in the denominator. The negative means that that's going to be in the denominator. The 24x cubed minus 2 is in the numerator. It has a positive exponent, so it just stays in the numerator. The 1/3, well, 1 times 24x cubed minus 2 is 24x cubed minus 2. The 3 here is down in the denominator. And so this power of 2/3, the 3 means the cube root, and then the 2 in the numerator just means that that's going to be squared. So that's why there's a power of 2 here. So that's the simplest version of writing this. Generally, you don't leave negative exponents, and you don't leave fractional exponents either. You write them generally as roots. That's a more accepted way to write an answer like that. Now in C here, we have like the second version there of the chain rule that was written on the last page. Y equals u cubed, and u is 5x minus x to the 4th. So I'm going to use this version of the chain rule. You will see that sometimes. So the derivative of y with respect to x is dy du times du dx. Dy du means just to differentiate y with respect to u. And so the derivative of u cubed, of course, just power rule. The 3 comes down in front, and then you subtract 1 from the exponent, so the derivative of u cubed is 3u squared. Du dx means to differentiate u with respect to x. So the derivative of 5x would be 5. Derivative of x to the 4th would be 4x cubed. And so that's the derivative. Now, generally you write this in terms of one variable. If it says dy dx, I want it in terms of x. So u here, remember, u is equal to 5x minus x to the 4th. So I'm going to substitute that in place of u. So it would be 3, and instead of u, I'll have 5x minus x to the 4th squared times, of course, the 5 minus 4x cubed. And generally the way I would write this is I would write this beside the 3. If it happened to be a monomial like the 4x cubed, I'd multiply by 3 to get 12x cubed. But it's a binomial, so I could multiply the 3 in, but this is more of a factored form. So 5 minus 4x cubed times 5x minus x to the 4th squared. So that's my derivative. Now just to show you a little different way to do this, if instead of using this version of the chain rule, if you said, well, okay, y is u cubed, so this is u. So I could actually write y as, if I substitute this in place of u, it's 5x minus x to the 4th cubed. Okay, so that's another way to write that function. So using the chain rule like we did in A and B, the derivative of a power of 3, the 3 comes down in front, decrease the exponent from 3 to 2, subtracting 1. Evaluate it at 5x minus x to the fourth, and then we multiply by the derivative of in here, which of course is 5 minus 4x cubed. That's the derivative of what's inside here. And this actually is really the same as what's written here. There's the 5 minus 4x cubed on the end. 3u squared, well, this is u, so 3u squared is really the same as 3 times 5x minus x to the fourth squared. And then, of course, I would just rearrange like I did here, and there's my same derivative.